Now our second drawing, we're going to go and we're going to add to the complexity of this first drawing. And I want to talk about how you would draw another cube on this same ground plane that would be the same size but in a different location. Okay, so how tall do you make your cube if it's sitting over here? Well, if it's in the same line, I'm going to reinforce with red our base square. So if I want to put my next cube that I'm going to draw, say, here in this square. So I know that that's a perfect square in perspective because I have this very nice grid that I've just constructed using the 45-degree vanishing point and the left and right vanishing point. So if I want to put a cube here, I've already got the height because it's going to fit if it's in the same plane. In other words, if it's in the same row of squares, then it's going to go to the same vanishing point. So all I'm going to do here is, starting with the front edge, I'm going to draw that corner up to the orthogonal going to the right vanishing point. I'm going to do the same thing from the left corner and then complete the top edge. Now, I'm using this orthogonal going to the right vanishing point. However, remember, this plane faces this direction, this plane faces this direction. So from this point, from the top of that front edge, I have to go to the left vanishing point. And then from this corner, I will draw my vertical going up to that line that I just drew, and then complete the top of that cube. So that's how you would draw a second cube, perfect cube, in two-point perspective, sitting closer to the right vanishing point. So this is a little bit more complicated because it's not in the same plane as our front perfect cube. So how do we find the height of the front edge of this cube? Well, we're going to stay in the same plane, and we're going to go out to the edge. We're going to go to the corner of this cube. So this is the front corner of the cube next to the one that I am about to draw. So I'm going to put the front edge in on that cube, and then I'm going to go to the right vanishing point, because it's in the same plane with this cube here. That now gives me the top edge of this new cube. So I'm going to draw the front edge. Then I'm going to go to the left vanishing point, and I've already gone to the right vanishing point. So now all I have to do is find the vertical that goes only to that line that I just drew. My right vertical is going to be hidden by the edge of my large perfect cube, and then I've already got the top edge going to the right vanishing point. So now I have a perfect cube, same scale. So if this is 10 by 10 by 10, this is also 10 by 10 by 10. This is also 10 by 10 by 10. Okay, now we're going to get to the point that we can do some kind of fun things with our perfect cube. So I have a cube here without the ground grid, and I have two squares up here on the top of the page that's going to help me illustrate what I am going to want y'all to do. So we are going to build some complex structures based on a perfect cube. So one thing that we want to do is to figure out how, if we're going to add things to a cube in perspective or take things away from a cube in perspective, how do we do that and maintain our scale? So thinking about adding and subtracting from a structure, we're talking about balconies, doorways, windows, added wings on one side or the other. That's kind of where we're going. So I want to talk first about multiplying. So if you're going to multiply the length of a cube by a certain amount, there is a way to do that. Now you won't just, if I want to double the length of this side of my cube, I can't just measure this and transpose that same measurement, because it's in perspective. That distance gets less as we go farther away from the station point towards the vanishing point. So in our left square that we have up on the top of the page is where we're going to talk about multiplying by a consistent factor. We're going to do this first on a square that's facing the picture plane. So if I want to multiply the sides of the square, if I want to multiply by a certain factor, I'm going to make this a little bit darker so that you can see it clearly. So the first thing we need to do is we need to find the center of the square. The best way to find the center of a square is make an X, a diagonal line that goes corner to corner in both directions, and where those lines cross, that is the center of the square. So that's the first thing that we're going to do, is find the center of the square. Then we are going to find the midpoint of the sides of the square. So that's going to be a horizontal line that passes through that center intersection. And then same thing on the vertical. So now I've divided my square into 4 smaller squares. Now I'm going to divide those 4 squares again. So if I want to extend this square, if I want to repeat that square one more time, going to the right, I'm going to draw a line from the top left corner through the midpoint of the right side of my square. And then I will draw a horizontal line extending the baseline of my original square. And then I will draw a vertical off of that intersection. And then I will draw a horizontal. Oops. And that's very easily, with no measuring or counting measurements, that's very easily allowed me to duplicate my original square. You can also do this with a rectangle. It doesn't have to be a square, it just has to be a cubic shape. Oops, oops, oops. Okay, so there we go. There's my additional square. Now I'm going to extend on this side. What if I only wanted to extend half the width of my original square? Well, in that case, I'm going to go, so if what that means is I want to duplicate this rectangle, vertical rectangle, that's half of my original square. So in order to do that, I'm going to go from the top corner through the midpoint of the opposite side. So that will look like this. And then I will extend the baseline horizontally, and that will give me the left corner. Oops. And then I will connect the top. And there you go. Without having to make any measurements, I have duplicated or multiplied by half the shape that I have started with. So, what does that help us do here? Well, if I wanted to make this cube wider by half, then going in that direction, then I'm going to find the center of this left plane by drawing an X, a diagonal on both sides, and where they intersect, that is the center of that box. Now, how do I find this line? Well, here it's horizontal. That was easy to do. We're in perspective, so I'm going to go from the intersection of the X that marks the center of the box to the vanishing point. If I want to extend by half, then I'm going to go from the top center mark through the left center of my cube. And instead of going down to a horizontal line that's extended off the horizontal bottom of my box, bottom of my square, remember I'm in perspective, so I'm only going to take this new line, this new diagonal, down to the bottom orthogonal going to the vanishing point, like so. So there I have the bottom of this new section. And then I will draw a vertical off of that corner. Now what happens if I want this new section only to be half as tall as my original cube? Well then I'm going to stop at that midline make sure I'm vertical. There's my midline. Now, what do I do here to complete the top of that form, right? Because it just looks like a door right now. I want it to look like a part of the cube. So from this point, I go to the right vanishing point. It's just like drawing a cube. From that top left corner, I'm going to go to the right vanishing point. And I have a balcony. Now, if I wanted to draw a porch roof coming out from the top of my building, then I'm going to think about how long I want it to be. And then I'm going to draw a vertical line. And then I'm going to draw going to the left vanishing point. And because this roof is partially above and partially below the horizon line, I don't see the top or the bottom of that roof. But I have found a way to multiply by consistent lengths and also to draw something of a height that I want it to be. Okay? So you can add all sorts of elements to your building. I also might think about how would I create a door. So this is how we're going to use dividing our square. So I'm going to reinforce the lines on my square. And I'm going to divide it again, and I want to think about how tall I want the door to be. So if I think about how tall I want the door to be, I got to think about how tall my building is. So if you think about stories, like stories in a building, you're going to average 10 feet per floor of a building. So if this is 10 feet, this is 10 feet, then the height of the whole building is going to be 20 feet. Then I want to think about the height of a doorway. So a standard doorway is going to be 7 to 8 feet, depending on what you want it to be. I'm going to say I'm going to make my doorway 7.5 feet tall. So if I divide the height of the building into, that's 10 feet. If I divide that length by 2, that's 5 feet. And if I divide that by 2, that's 2.5. So that's going to give me my 7 feet. Okay, I'm just doing simple dividing by factors of 2. So if I do that, I'm going to divide my... So if I've got a 20-foot overall length, that means each of these sections are 10, which means these sections are 5. And these smaller sections are, those are 5, and then these smaller sections are 2.5. Okay, so 7.5 feet is going to be this level right here in our overall 20-foot height. Okay, so then how wide do I want to make my door opening? So I think I'm going to make it 5 feet wide. The center of my square, and if each one of these small sections is 2.5, that means I'm going to go 2.5 in this direction and 2.5 in this direction. So my door will then be 7.5 feet tall by 5 feet wide. So then I'm going to erase. So there I have my door opening. That is 7.5 by 5. Okay, how do we transpose that? And all of the intersections in the middle of these squares should line up with your vanishing point. So now I'm simply going to count. 1, 2, 3. 1, 2, 3. That's going to be the left part of my door. And 4, 5 is going to be the right side of my door. And then I'm going to count up 1, 2, 3. So I'm going to go up 1, 2, 3. Here's the top of my door opening. So this is why you want to use a really light hand when you are drawing all of these grid lines. I went a little bit darker so that you could see it, but you want to be able to erase cleanly. So now, to give the inside of my doorway dimension, I'm going to go from the bottom left, or the bottom right of the opening, the bottom left of the side of the wall, to the vanishing point. And this, you can just pick how deep you want your wall to be. And then I'm going to draw a vertical line to connect, so that I've now given that wall dimension. Okay, you can add windows the same way. You can take away sections if you wanted to take away underneath the porch and make that porch not solid but on pillars. You can do that. So what you're going to do when you want to repeat a word or a pattern from a square to something in perspective, you're going to start with your grid. And I'm going to count above the doorway 1, 2, and I'm going to indicate where that sign hangs on the wall. So what I want to do is I want to, on each section, I want to put a mark wherever my letters cross one of these sections. Over here, and you want to make sure that you get accurate in terms of from this length to this, where that intersection is. So it's a little bit closer to the corner than it is to the intersection, and it comes up right here and right here. So then when I go to transcribe it, I've got a map. Place it on a ground grid, and I want at least 2 structures. Okay, and I want additions and subtractions on your structures. So your completed drawing will be somewhat like this, where you'll have more than one structure. and you'll have additions and subtractions and at least one transposed sign. I want the ground grid to be in the drawing. So once you get your perfect cube, you can erase inside the cube, so keep those grid lines light. And I want you to also embellish your second structure. Now, we didn't talk about when you create a structure that's, say, twice the height of your original cube, but farther away in perspective. So here I have drawn my first cube that is the same scale as the original, and then all I did was measure the height of that edge closest to us and doubled it. Okay, this is the one time that you can just measure something and double it. So I've doubled the height and go to the left and right vanishing point from that front edge. So this should be kind of fun, kind of interesting to figure out how complicated you can make this structure. So this is probably a B, complication. If you want an A, then you're really going to have to add a lot to your original cube and your secondary cube. Okay? The only thing you cannot put on this is a pitched roof, because that's a different perspective game to have a pitched roof. So your structure needs to have a flat roof.